In this lesson, we are going to solve problems involving maximum, minimum, and example 1 is a bullet fired vertically has a height h in meters. After t seconds, the equation is given h equals 100t minus 5t squared. The question A asks you to find the maximum height reached by the bullet. So when you have a question that asking you for maximum, then the given is a standard form. You may think if we could have the h equals a bracket t minus p bracket squared plus q form, the vertex form, then the q value will be your maximum or minimum value. So whenever you see the question is asking you for maximum or minimum value, then if it's given in standard form, you could think to use completing the square to convert from standard form to vertex form to solve the question. So from this question, we are going to start with the standard form h equals 100t minus 5t squared. And we know that this is a standard form, but the standard form need to be ax squared plus bx plus c. So the degree need to be from 2, 1, and 0. So we need to rewrite it as t squared first, then plus 100t. And because the number at front of t squared is not 1, so we need to take the negative 5 out and divided the terms with t by negative 5. So negative 5t squared divided by negative 5 give you t squared. 100t divided by negative 5 give you negative 20t. And you could use a box method, or you could use a traditional method, add half b bracket squared. So I will use a box method. We put the t squared in the first box, then minus 20t, we want to split it into half. Negative 20 divided by 10 divided by 2 give you negative 10, negative 10. Then we factor the first row, greatest common factor is t. So t squared divided by t is t, negative 10t divided by t is negative 10. Then negative 10t divided by t is negative 10. Then you will see now we have t minus 10 times t minus 10, we have t minus 10 bracket squared. So this is, we use a box to do the factoring, then we close the box. This one outside is no constant, means plus 0. So in this outside of the bracket is plus 0. In this box, we need to have positive negative 10 times negative 10 give you positive 100. We need to have this t squared minus 20t plus 100, the trinomial. Then we could factor it as t minus 10 times t minus 10. Then in the bracket, we don't have constant term, so we need to minus 100 to make the constant term is 0. Then we expand, take the minus 100 outside of this bracket. So it will be minus 5 times minus 100, then plus 0. So we collect the like terms. You will have minus 5 t minus 10 bracket squared plus 500 and compare this one with the vertex form, then we know A is -5, P is opposite with a number inside the bracket is +10, and Q is 500. So from this vertex form, then we know that the maximum, this is open down, so maximum will be at the vertex, and the maximum value is your y value. So the maximum height is 500 meter. So the x is your t in seconds, and the y coordinate is height in meters. So this is for question A. From this you will see from standard form, once we convert it to vertex form, then we could find the maximum or minimum height easily. And for question B, it asks you how long does it take to reach the maximum height. So at the vertex, the time is 10 seconds. So at 10 seconds, the bullet reached the maximum height, 500 meters. So question B, once you have the vertex form, then you have the time and the maximum height at the same time. So the second one is it takes 10 seconds to reach the maximum height. So that is done, okay. So the key here is asking for maximum, minimum, then this is in standard form. You may think that you need to convert it to a vertex form, okay? Then we are going to practice another example. So example 2, computer games are sold to students for $20 each. For every $1 increase, there are 6 fewer students willing to buy the game. A model to represent the revenue in dollars for every X dollar increase in price is given and asks you what's the maximum revenue. We know this is ax squared plus bx plus c. This is a standard form. It asks you for the maximum revenue, then we could try to convert this one to vertex form. So this is asking for maximum, then we could start from convert it to vertex form. So we are going to group the first 2 terms. It's -6 x squared plus 180x, then plus 6,000. So we take the -6 out. The reason for that is we want the x squared inside the bracket, then you will have x times x, then you will have same factors, and you will have perfect squared. So for this question, I want to show you the add half b bracket squared. So add together using the x game. Add together is -30, then we do backward. We want these 2 numbers same, so it will be -30 divided by 2 is -15. Then -15 times together give you -15 bracket squared. So this is a half b, then this is half b bracket squared. So if this is 225. Then inside the bracket, we want to add this 225 here. Then once we have 225 here, it is we are looking for two numbers times together 225, add together -30. The two numbers will be -15, -15. Then you will have perfect squared, x minus 15 bracket squared. Then inside the bracket, we don't have constant, so we are going to minus 225. So inside the bracket, no constant, so this one is 0. Then we copy the constant outside 6,000 outside of the bracket. Then the first three terms, we factored it as x minus 15 squared. And the fourth term, we didn't use it, so we are going to take it out of this three term outside of the bracket. It will be -6 times -225, then plus 6,000. Then we are going to collect the like term to write the final vertex form out. So -6 times x minus 15 bracket squared, this is 1,350. Then plus 6,000, you will have $7,350. Then from this one, compare it with vertex form. A bracket x minus p bracket squared plus q. So a value is -6, p value is 15, q value is 7,350. So on the graph, if we sketch it, you will have p value is x coordinate, q value is y coordinate. So the vertex is here and the right one down 6. So you have something that is a problem open down. So at vertex, you will see you have a maximum revenue. So the y-axis is revenue, x-axis is $X increase. So we write the statement here. The maximum revenue is $7,350, and the selling price, be careful here, 15 is the $X increase, so the selling price is not $15, it's from the original price $20, then increase $15. That is the selling price, $35. Okay, so this is for this question. Then we are going to see the next question. So the next question is a rectangular field to be enclosed by 1,200 meter fencing. Find the dimensions of the field that give a maximum area. So we draw a rectangular field. So it should be 90 degrees. And you have 1,200 meter fencing, okay? It asks you find the dimension, so we are going to introduce, maybe we introduce width equals x, at x equals width. And you may have done such question in elementary school by trial and error, but in this course you need to do it the way algebraically, okay? So x equals width, then we want to find this side. Altogether, you have 1,200 meter fencing. So you use x at these two sides. So whatever left is 1,200 minus 2x. This is whatever left of fencing. Then we want to put this one at these two sides. So it means this whatever left need to be divided by 2. So this is width, and the length will be 1,200 meters. Take away the 2x, and whatever left will be put to the opposite two sides. So we do the division, you will have 600 take away x. Then it asks you to find the maximum area. So the y value will be the word after the maximum or minimum. So y is the area. So let y represent the area. Then for a rectangular field, the y equals length times width. Then length is 600 minus x, then times the width is x. So this one is a factored form. So we could rewrite this one as 600 take away x, then times x. You could x by itself, or you could write x minus 0. So then if this one is in factored form, then we don't have to use a completing the square. We could, by finding the zeros, then find the midpoint to find the vertex. So the zeros will be the x-intercept. These zeros means the y equals 0, then each bracket equals 0. So 600 minus x equals 0, or another bracket x equals 0. So move the x to other side, solve x isolated. So we are going to have positive x equals 600. So you have the zeros 600, 0, and also 0, x equals 0, y equals 0. So from the two zeros, if we sketch it, you will see you have 0 here, you have 600 here, so you have two zeros, and y is the area. So the middle of these two zeros is the axis of symmetry. So it will be average of the two zeros. So 600 plus 0 give you 300. This is your p value, x value. Then we are going to find the q value. Q value is you sub in the x equals 300 back into the equation 1. Then we are going to have 600 take away 300, then times 300. So replace the x with 300. Then we do the calculation, you will find out it's 90,000. So this is a vertex. This is 300, and the y value is 90,000. So from this vertex, then you will see the y value is the area. So we are going to write a statement. So the dimension one side is 300. The another side is 600, take away 300. It will give you 300. So the length is 600 minus 300. So the statement will be the dimensions The dimensions are 300 meter by 300 meter. That will give the maximum area. Okay, so this is for example 3. You need to set up the equation by yourself. And again, for this grade 10 course, we are going not asking you to set up equation. The equation will be given, okay? But you need to use this algebraic method to solve the dimensions. And the next example, it asks you find two numbers that differ by 6, and the product is a maximum, minimum. So once you see maximum, minimum, then this is looking for the vertex. And we want to introduce two variables. So let x represent, you want to find two numbers, we are going to let x represent a smaller number, or you could represent a larger number. So if x is a smaller number, then the two numbers differ by 6, then the larger number will be x plus 6. And the product is a minimum, so we are going to let y represent the product. And if we could write it in the vertex form, then find the vertex, and the y value is a maximum, minimum, okay? So product means multiply, so the two numbers product is a smaller number times the larger number. And again, you see this is a vertex form. So from the vertex form, it's easier for you to find the, this is a factor form. From the factor form, it's easier for you to find the zeros. So this one you could think is x minus 0. Then this is x plus 6. So the zeros will be opposite with a number in the bracket. Or you could solve x minus 0 equals 0, x plus 6 equals 0. Then you want to isolate x, so you move the number to other side, will be opposite. So this is x equals 0, x equals negative 6. Then again, we could find the vertex by looking for the midpoint of the two zeros. So 0 plus negative 6. And you will have negative 6 divided by 2 give you negative 3. So this is p-value, the x value. Then for the q value, we sub in x value to the equation 1. So replace x with negative 3. So negative 3 times negative 3 plus 6. Then you have negative 3 times positive 3, give you negative 9. So this one is a product, and the a value is positive, so we have the p value is negative 3, q value is negative 9, and the step pattern a value is 1, so it's right one up 1, left one up 1, right one up 3. So you will have a graph probably like this. Then from here you will see at the vertex you have a minimum. Then that is your minimum product. So therefore, the two numbers are negative 3 and this is a smaller number. The difference is 6, means plus 6. Negative 3 plus 6 is positive 3. That whose product is minimum. Okay. Is a minimum -9. So this is today's lesson, and today's lesson, if it's given standard form, then we want to do the completing the square. And if it is a factor form, then we could just find the zeros, then find the midpoint, then sub in the x value, the midpoint, then you can find the y value, that is your q value. Then from the vertex, you see, you could find the maximum or minimum value easily, okay? Thanks for watching.